in this video, we're going to be looking at identifying relations. By the end, you should be able to represent relations as sets of ordered pairs, tables, mappings, and as graphs. The word relation, what does it mean? We see this word relation in the word relationship. So what type of people do you have a relationship with? Well, we see parent-child relationships, we see teacher to student, we see sibling relationships, coach to player, and then like girlfriend and boyfriend relationships. Mathematical relations are no different than this. They describe how different sets of data are related to each other. One piece of data is typically dependent on another, just like personal relationships, how a child is dependent on a parent or a student is dependent on a teacher. Mathematical relations are no different than this. To put an algebraic definition to a relation, it's a set of pairs of input and output values. You have something that is inputted, and you get an output or an outcome as a result of that. It's also how two different variables have a relationship. So you have two distinct items, and we look at how they're related to each other. Sometimes there's a pattern to them, and sometimes there's not. Relationships can be represented, they can be organized so that we can examine them and study them a little bit further in a variety of different ways. Some of those ways include as ordered pairs, as tables, as graphs, equations, mapping diagrams, and as a verbal description. When we talk about this equation, it's this y equals mx plus b equation. Or we'll study it a little bit later on, but a quadratic equation or an exponential equation, whatever type of equation that there is in algebra, it is a way of representing a different type of relation. Ordered pairs are the same way. Graphs are the same way. We see various different types of graphs. We see mapping diagrams like we have here, all of which are used to organize our data so that we can observe and study their patterns. When we get into this idea of relations, and specifically when we get to functions, there's this concept of independent and dependent variables. An independent variable, this is a variable that is not contingent upon something else. Does not rely on something else. It kind of stands alone. Your independent variable is also going to be called your domain. These are all of your x values. So when we talk about independent variables or your domain, these are the values that would lie on your x-axis if you're looking at a graph. They would also be represented by an x-coordinate. If you're going to use a variable other than x, just make sure that whatever variable you use is first alphabetically and it comes before your dependent variable. Your dependent variable is dependent, okay, it relies on or is contingent on your independent variable. So your independent variable changes, it also changes your dependent variable. So your dependent variable relies on your independent variable. Your dependent variable is called your range. It's all of your y values. So it's the set of all of your y values. So these are going to be the values that lie on your y-axis. And again, if you're using a different letter to represent, or a different variable to represent your dependent variable, make sure that it comes after your domain, so it's second alphabetically. We get into this idea of function, and we'll dive into functions a little bit more in the next video. But a function is when an output depends on a specific input. So whatever you put in, you put something in, you have a specific input. Okay, so you have a specific input that goes in, and you get the same output every time. So the way that I like to equate this is to a soda machine. If I press a certain button on a soda machine, so if I press the button for Coca-Cola, I know that every single time I'm going to get out a Coca-Cola. Alright, let's consider this pattern. So this pattern actually looks at the number of squares and its perimeter. This pattern can be represented in many different ways. You can organize it in a table, so you can put the number of squares in for your x, the perimeter in for your y, and you can organize your data that way. What this allows you to do is it allows you to then pull and look at the different ordered pairs. So I can take my points from here and I can write them, or I can list them as ordered pairs. So another way to represent this pattern. once I have a set of ordered pairs, what I can then do is I can graph it. So I can then plot these points, and I can look at them and I can see the type of pattern. Is it increasing? Is it decreasing? Is it linear? So these are different types of ways to represent and organize, and it kind of gives us a different idea. What a mapping diagram does is it takes all of your inputs and it puts them in one bubble. So it takes all your inputs, all of your independent, puts them in this first column, takes all of your ranges, all of your outputs, and puts them in the second column, and then it maps them to another. And what it does is it allows you to visually see how many outputs an input goes to. And so it allows you to kind of determine if a relation is just a relation or if it's a function, if it's a little bit further. You can also organize this pattern as an equation. So we see that to get the perimeter, which is y, you take the number of squares, you multiply it by 10, and then you add 10 to it. And if we were going to describe that using words, it's exactly what we would say. So we would say this pattern shows that the perimeter is the number of squares times 10 plus 10. Sometimes we're asked to represent a verbal description using a graph. So we're asked to illustrate whatever pattern is going on. And all of these graphs have in common, they're looking at some type of quantity over time. So we look at this first one. It says during a trip your speed increases. So we show that it increases over the first hour, and then it steadily decreases, then it decreases over the next 2 hours. So we show that it increased, and then it started to decrease, and so you would represent that. We look at the next one. It says the average temperature steadily increases, so over time our temperature is increasing. Our temperature is decreasing. So over time our temperature is decreasing, and that's it. Then we look at our last one. It says the average test score of a class increased throughout the semester. So over time, the average test score is increasing throughout the semester until the last test where it slightly decreased. So we would show a steady increase, and then we would show a slight decrease over time with that final assessment. And there are other times where we're asked to kind of describe what's happening in our graphs. We're asked to give a verbal description. So we'll pick a couple of graphs here. Let's look at this college GPA. So we can see that we're looking at different majors. So we're looking at art, English, history, and math. These are independent. And what we see is that the GPAs for art are higher, and then the GPAs for English and history are lower, and then for math it increases. Again, so we're just describing kind of what's happening. But our independent here would be psychology. Our dependent would be the mean GPA. And then describing it, we would just say typically art and math have higher GPAs than English and history. We can look at the second one. It's looking at the height in feet over time. So what we see is that over time, a hot air balloon, it is increasing. And then it stays at a constant height for quite some time. So the height doesn't change for maybe several hours. And then over the course of the next few hours, it steadily decreases. So again, we're looking at just the different types of ways to explain or represent a graph. If we look at this third one, and this is the last one that we'll look at, we can see the speed of a taxi driver. So we see that it increases, and then it stays steady. Then it decreases, and it comes to a stop. And then that pattern kind of happens over and over again. So what we could say is that he picked somebody up, accelerated, drove at the same rate, then decreased, stopped, and then picked somebody else up. And so you're just kind of describing the graphs based off of that. Alright, so one of the things that I would like for you to consider before watching the next video is the difference between a dependent and an independent variable. So kind of chew on that and see if you can't explain the difference between those two things.